the inverse of the exponential function. Until now, we have learnt to determine the inverse of the linear function and the quadratic function by reflecting the graphs about the line y equals x. We will now learn to determine the inverse of the exponential function. Consider the exponential function y equals 2 to the power x. An exponential function is a one-to-one relation, hence the inverse of the function exists. We interchange the variables x and y. X equals 2 to the power y. Note here that y is an exponent, and we need to make y the subject of the formula. It will not be possible for us to solve for y using any of the techniques of algebraic manipulation that we have learnt so far. How do we do this? Well, let us try to do this graphically. We reflect the graph of y equals 2 to the power x along the line y equals x. We have now obtained the inverse of the exponential function, known as the logarithmic function. Note that the function x equals 2 to the power y can be written as y equals log x, base 2 in logarithmic form. We can see that the graph of the inverse function passes the vertical line test. Let us now learn the characteristics of the logarithmic function. Domain. X can take any positive real value. It can never be 0 or less than 0. Range. Y can take all positive values as well as the negative real number values as the curve extends infinitely above, as well as below the x-axis. Intercepts with the axes. The inverse of the exponential function cuts the x-axis at 1, 0. X-intercept 1, 0. Increasing or decreasing function. The graph of f inverse x exhibits an increasing trend. As x increases, the y value also increases. Asymptote. The function comes closer and closer to y-axis, but never intersects the y-axis. Average gradient. Average gradient between any 2 points, A and B on the curve, is the gradient of the straight line passing through these points. Shape and symmetry. The inverse of y equals a to the power x, that is, y equals log x base a, is symmetric with respect to the y-axis, when x changes from positive to negative. Observe the graphs of y equals log x base 2 and y equals log minus x base 2. Similarly, the inverse of y equals a to the power negative x, that is, y equals minus log x to the base a, is symmetric with respect to the x-axis when y changes from positive to negative. We can conclude this by observing the graphs.
Need more help? Subscribe to our channel. Can't wait that long? Ask Masky to help you and let the math finally start mathing.